Hi, let us start off with some tutorial question. We're going to do tutorial one, question number 1. Right, question number 1 presents to you very simple calculation pertaining to cross product. In question number 1, you have 3 vectors. The vector A, which is 1, 1, 0, right? Then the vector B, which is 1, 0, 1, and then vector C, which is 0, 1, 1. So in question number 1, you are given 3 vectors A, B, and C. In part 1, right, you are asked to find A cross B, A cross B. How do you find A cross B? Again, you cover the first row and then you do that determinants calculation. You get 1. You cover the second row, again you get 1. But as I told you, for the middle row, right, you need the extra minus. And then the third row, when you cover third row, you get a minus 1. So this is how you get the answer I minus J minus K. Then part 2, B cross C. So you have 1, 0, 1 cross with 0, 1, 1. Okay, again you cover the first row. You get 0 minus 1. Cover the second row, you get 1 minus 0. But I told you, we know it already. By now you're very familiar. The middle row need an extra minus. And then cover the third row, you get 1. So you get minus 1, 1. Then part 3, you have A cross B cross C. So you're supposed to do A cross B first. A cross B is this vector, which is 1 minus 1 minus 1. Cross with the vector C is 0, 1, 1. Right? So again, you cover the first row, you get 0 for the first entry. You cover the second row, you get 1, but middle row needs an extra minus. Cover the third one, 1, again 1 minus 0. So you get 0 minus 1, 1. And for the part 4, you are asked to find A cross B cross C. Okay, A is 1, 1, 0, 1, 1, 0, and then B cross C. B cross C is this, is minus 1, 1. So again, you cover the first row, you get 1. You cover the second row, you get minus 1. You cover the third row, you get 0. Right, this therefore is I minus J 0. Now each time you perform a cross product, right, like this, it's always good to check that this is correct by taking this, the dot product with this. This, when dot product with this, must be 0. This, when dot product with this, must also be 0. So you can check mentally, true or not. You take this vector, right, you dot product with this. So it'll be this times this plus this times this plus this times this. Indeed, it's 0. Likewise, you check this one with this. So this times this plus this times this plus this times this. Again, is 0. So only when you have checked, then you're very sure that you are correct. Okay, that's actually question 1 of tutorial 1. Let's look at number 2. Okay, in number 2, you are given 2 vectors, OA and OB. OA is given to be 1, 2, minus 2. 1, 2, minus 2. And OB is given to be 2, minus 3, 6. Okay, in this question, there's a third point P, and third point P, according to the question, is like this. So maybe this is origin O, there's a vector, there's a point A and this point B, and this origin O, there's OA and OB. So this vector OA, this vector OB, P may be somewhere here. And then you're told that the point P is on the line AB, and point P divides AB in the ratio of lambda is to 1 minus lambda. I hope you do remember this thing called the ratio theorem. Do you remember ratio theorem? We can use the ratio theorem to find the vector OP quite quickly. How do we apply the ratio theorem? The ratio theorem says to find the middle vector, the OP, right? Ratio theorem says you take this ratio times this vector OB plus this ratio times this vector OA, and then divide by the sum of the two ratios. So according to the ratio theorem, this therefore is lambda of OB plus 1 minus lambda of OA divided by the sum of the two ratios. Once again, how ratio theorem goes, you take this ratio times OB plus this number times OA divided by the sum of these two numbers. Okay, so if you were to plug it in your OB and plug it in your OA, and then you tidy them up, you will eventually truly get this for OP. You get 1 plus lambda, 2 minus 5 lambda, and then minus 2 plus 8 lambda. Right? You just have to plug it in, you know. We take lambda times OB plus 1 minus lambda times OA. So you put OB here and put OA here and tidy up arithmetic. The good thing is, in this case, right? In this case, you want to realize that the denominator actually adds up to 1, so it doesn't come to picture. Right? You see that this is the case. The denominator adds up to 1. Okay, so this is the vector OP. And in part A, right? They want you to find lambda such that OP is perpendicular to AB. You want OP to be perpendicular. How can OP be perpendicular to AB? Or if OP is perpendicular to if OP is perpendicular to AB, what can you say? If OP is perpendicular to if OP is perpendicular to AB, we learn that if two vectors are perpendicular, there is a nice result that we know from dot product. Do you remember what is that? Earlier on, we did a comparison, remember? We did a comparison between dot and cross product. And then I have also highlighted to you that when two vectors are perpendicular, so if in part 1, if OP is perpendicular to AB, then we learn that the dot product of OP with AB is equals to 0. So what I can do is, right now we take the vector OP, which is 1 plus lambda, 2 minus 5 lambda, minus 2 plus 8 lambda. You want to dot with the vector AB. What is the vector AB? Vector AB is OB minus OA. Vector AB is OB minus OA. So this gives you 1 minus 5, 8. This will give you 1 minus 5, 8. And then perform the dot product to take this vector to dot product this vector. For me, what I normally do is I deal with the numerals first. I take 1 times 1, 2 times minus 5, minus 9, minus 9 minus 16 will give me minus 25. Minus 25. Then I'll do the lambda. 1 plus 25, 26. 26 plus 64. Okay. I get a value of 90. So I think I get 90 lambda equals 0. So that tells me that lambda is equals to, okay, not very friendly number. Okay, this is going to be, okay, 5/18. Right. So to answer part A of the question, not one, part A of the question, using this condition that because they are perpendicular, right, the dot product of these two is 0, I found that my lambda is 5/18. Okay, that's actually 3A. Sorry, 2A. Then now we want to do 2B. 2B again, 2B. In question 2B, you are told that the angle AOP is equals to angle POB. So what they're saying is these two angles are equal. This angle, and this angle are equal. Right. And then they want you to find the value of lambda when this thing happens. Now, if these two angles are equal, then what we can say is OA dot OP over modulus OP is equals to OB dot OP over modulus OP. Oops, let me write nicely. OP. All right. Why should this be the case? If you could recall, this calculation actually gives you the cosine of this angle, and this calculation actually gives you the cosine of this angle by virtue of the definition of dot product. Once again, this calculation gives you the cosine of this angle based on the definition of dot product, and likewise, this gives you the cosine of this angle. So they have to be equal. Since the two angles are equal, now we can do this cancellation of this. It is important to note that while you can cancel these two on the denominator, you mustn't cancel the OP and OP on the numerator. No, it's not the same for dot product. The reason why I can do so for the denominator is because these are numerous, just a number times a number. That's okay. But for the numerator, this can't be done, right? So what we're going to have here is we are going to now do the dot product of OA with OP on the numerator, then divide by the modulus of magnitude of OA, and likewise on the right hand side. So this is your OA and this is your OP, right? This is your OA and this is your OP. Now you want to perform the dot product of these two, OA with OP for the numerator. So let's do the dot product. Again, when I take OA to dot with OP, I always do it this way. No? I deal with the number first. 1 plus 4 plus 4. So it's 9. So that gives me 9 for the first number. And then 1 times lambda minus 9 lambda plus 16. Sorry, minus 9 lambda minus 16 lambda is minus 25 lambda. So that's minus 25 lambda. That's for the numerator. And then for the denominator, right, we need the magnitude of A. How to find the matrix of A? Square, 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 added together and square rooted. So it's 3. Likewise, when I do the dot product of OB with OP, same thing though, I give a number first. 2 minus 6, so it's minus 4. Minus 4 with a minus 12 is minus 16. Okay, then the lambdas, 2 lambda plus 15, 17 lambda, 17 lambda plus 48, 65. So I get 65 lambda for the numerator. And then I find the matrix of B is actually 7. How do I get 7? Square, square, square added together, square rooted. So you get square root of 49. Alright. Now you want to do your arithmetic, no? Okay, so you cross multiply them. You got 63 minus 175 lambda minus 48 plus 195 lambda. Right. So if my calculation is correct, this is 111, and this is going to be 370 lambda. So my lambda is 111 over. It's not a nice number. Okay. So for number 2b, right? As I said, this is not a very nice number. It looks like a very bad number, but it turns out to be just 3 over 10. Right? You just divide by 37, you get 10 on the denominator, divide by 37 on the numerator, you get 3. So you get 3 over 10.